All right, concept 2, solving x squared plus bx equals c by completing the square. So notice that we do not have a variable or a coefficient on our first term on our x squared. Right now we're just looking at ones without. And we're looking at ones that aren't in standard quadratic equation form, although we will look at what to do when they start that way. Okay, so we've got our problem here. We know we're going to solve this by completing the square. So what I'm going to do is rewrite it so I've got a little more room. X squared plus 6x, and then there's going to be something else there, and then it's going to equal -8. Okay, use your formula to find out what your third term is going to be. And remember, that's half of that second term, so 6 divided by 2 squared. 6 divided by 2 is 3. 3 squared equals 9. Okay, so I'm going to add 9 there, and I'm going to add 9 here. All right. One problem that does crop up with students completing the square is they will put their value in here to complete the square, but they'll forget they've got to add it to both sides. Okay, so keep that in mind. You always got to do the same thing to both sides, just like we've always done. All right, we've got our perfect square trinomial. It is going to be x plus 3, right? And that's going to equal 9 plus a -8, or 1, okay? Oh, and squared, okay? And now I've got my problem down to one that we did in our last lesson, starting with that, the square of a binomial factor, okay? So, square root both sides gives me x plus 3 is equal to positive or -1. And go into my two cases. I've got x plus 3 equals 1, and x plus 3 is equal to -1. All right, and I subtract 3 from each side. 3, 3, 3, and I'd have x equals -2, or x equals -4. Okay, and those are my zeros. Right, not too much of a problem. Doesn't take a ton of steps, although we do have to start by figuring out what our third term is. Now, you might have looked at this and said, okay, I can see how we're doing that, but this seems like if I put it all on one side, right, my x squared plus 6x plus 8, right, because if I added 8 to both sides, that's what I'd end up with, equals 0. This seems like a really easy problem to factor, okay, and that's true. There is going to be overlap, and you're going to be choosing what method works best. In some cases, completing the square will work best, but in some cases, just looking at it and saying, oh, that's easy to factor, boom, that's what I'm going to do. I see that my two factors of 8 that add up to 6 are 4 and 2, so the opposites, because there's no value, there's no coefficient on A, the opposites must be my zeros. That's totally fine, okay? Choose the method that works the best. But sometimes you'll have a problem like this that is not factorable, right? There's no factors of 2 that add up to 12. So this will not be one we can solve by factoring. We'd have to graph it, or in this case, use completing the square. So if you have one that starts in the standard quadratic equation form, you're going to move that third term over, subtract 2 from both sides, have x squared plus 12x equals -2. Complete the square. So again, I'm taking 12 divided by 2 squared. Okay, my b divided by 2 squared, which is going to give me 6 squared, or 36. I add 36 to both sides. And now I have, excuse me, now I have a perfect square trinomial with factors of x and 6. Okay, and over here I have 36 minus 2, or 36 plus a negative 2, or 34. Okay, so square root both sides. X plus 6 is equal to the positive or negative square root of 34. And I know that this is not a perfect square, so it is not going to be something that I'm going to evaluate, at least not now. Okay, I'm going to finish the problem for my two cases, all right, and then I will figure out later on what the exact values are, or what the approximate values are. Okay, so subtract 6, subtract 6. I've got x is equal to the positive or negative square root of 34 minus 6. And now it'll really depend on the problem. Okay, if I was doing an engineering problem and I needed to be super precise, then I would probably take this out to, the thousandths or whatever. If I'm doing a really loose problem that doesn't matter too much, if I'm off a little bit, I might say, okay, well, the square root of 34, that's going to be real close to 6. So, it's probably something like 5.8, okay, and plus or minus 5.8, and that would be the way I'd get my zeros, okay, but it'll depend on the problem.